Welcome to Homework Help for Lesson 5.1, Properties of Exponents. We're going to start with a couple of examples since this is mostly a review lesson. So right here, if I have x times x times x, we all know x is being multiplied by itself 3 times, so we have x cubed. Another way to think about this is when we have an invisible exponent, the exponent we're really dealing with is 1. And so if I have x to the 1, which is x one time times x one time, and another x, the trick we're going to use, or the rule that we'll develop, is that we're just going to add up our exponents. So same here, I have x cubed times x squared. This really represents x 3 times x again 2 times, which is x to the 5th power. Again, we could get that in 1 second just by adding our exponents, since our exponents are telling us how many x's there are. So let's go to this rule over here on the side. And our first rule for today is when we have multiplication of the same variable, but with different exponents, then our rule is we're going to add our exponents. Let's apply that to problem number 1a. So I'm multiplying. This time I have not only variables, but also coefficients. And so we'll multiply our coefficients as usual. That's negative 12. And now I have x squared times x to the 3rd. We're multiplying, so we'll add up our exponents. That'll be x to the 5th power. Okay, let's do another type of example here. Now I have x squared to the 3rd power. So I can think of this in a couple of ways. If I have x squared, then really I'm dealing with x times x. And if I'm taking that to the 3rd power, well, I'm multiplying this by itself 3 times. And so in the end, I'm left with x to the 6th power. I have x times itself 6 times. Think about it another way. If I have x squared being multiplied by itself 3 times, hey, now we're multiplying again, so we can just add our exponents. I have 2 plus 2 plus 2, which again takes me to x to the 6th, because I have x 2 times, 3 times in total. So we're going to actually multiply these numbers to get x to the 6th power. Now let me make a clear distinction. Before, we were doing this, and then we would add our exponents. Now, if we take this exponent directly to another exponent, we're going to multiply. It's almost like the distributive property here. We're going to multiply them. So let's look at this example. Here I have 2 to the 1 power and y to the 3rd power. And we know that we won't be adding, but multiplying, because we're taking 2y cubed, which is basically 4y to the 6th power. I could have gotten directly from here to my answer bypassing this work by simply distributing. So 1 times 2 is 2, that's 2 squared. And then 2 times this exponent of 3 leaves me with y to the 6th power, and 2 squared is nothing more than 4. So there are different ways to think about these, but I'm going to be emphasizing our nifty little rules today, which said, actually it looked like this, which basically says if you're taking an exponent and raising it to another exponent, you're going to multiply. But everybody needs to get that same treatment. And so we can show our work like this. So let's go back to our rules and add one more. Oh, this is an important one. I just skipped over it. Anything to the 0 power is 1, not 0. And then this is the rule we just talked about. If I have, I'll write it over here since I missed it. If I have an exponent taken to yet another exponent, we're going to be multiplying them almost like we're distributing. And then the same goes here. If I have two factors, then every guy gets his own exponent. Again, it distributes in. And the same goes here. Whether it's in things are being multiplied or whether they're being divided, everybody kind of gets their exponent distributed to them. Okay, so let's do problem number 2a from the homework. Here I have these things all being multiplied, so I know I'm going to distribute in that third power to 3 different spots. So I've got 3 to the third power. Now when I have a squared to the third power, I'm really talking about a to the 6th. So our rule is to multiply. And now when I have b to the 4th to the third power, that really gives us b to the, not 7, but 12, because we are multiplying them. And that would be, once we simplify this 3 to the third, 3 times 3 times 3 gives me 27. So my answer is 27, a to the 6th, b to the 12th. Okay, same rules apply here. What's different about this problem is we have a fraction exponent. But what's the same is the rule to just distribute in. So I'm dealing with x to the 4th to the 1/2, and then y to the 6th to the 1/2. But we already know we're just going to multiply that. So 4 times 1/2 is 2, and then half of 6 is y to the 3rd. Over on the side here, let me just emphasize this. If this had been x to the 4th, y to the 6th squared, I would have done the same thing, except I got x to the 8th and then y to the 12th. I would have been multiplying by 2 instead of 1/2. All right, something new. Let's look at example 5. I have x to the 7th divided by x to the 3rd power. So let's talk about what's going on exactly. So no longer are we multiplying, now we are dividing. So I'm going to rewrite this as x to the 7th, which means that I have 7 x's, divided by x to the 3rd. And so if I look at this, I know that I can simplify these because they're all being multiplied together. So I can cross out 3 of the x's, because they're duplicates on the top and bottom. That leaves me with, well, if I had 7 originally on top and I take away 3, I'm left with x to the 4th power, these 4 right here. Notice what I said. I said I took away 3. It's almost like I'm subtracting. I did x to the 7 minus 3, and I was left with x to the 4. Now, here's a common mistake. Sometimes kids are not sure whether those 4 are left on the top, like here, or if they're left on the bottom, like here. The trick is, wherever the bigger number started, in this case it's in the numerator, that's where the leftovers are going to appear. So when you do the subtraction problem, you're going to write the exponent wherever the bigger number was. Let me show you an example of where it's going to be switched. So for example 6, I have x to the invisible exponent here is 1 over x to the 3. So let's think about this for a second. I have 1x on top and I have 3 on the bottom. That means one pair will cancel and I'm left with, well, if I do the subtraction, 3 take away 1 was 2. So I'm left with x squared, but not on the top. That's where the smaller number was. I'm left with it x2 on the bottom, as you can see here. So we have 1 over x squared. So you're going to do the subtraction, whichever way leaves you with a positive number. 3 take away 1. In this case, it was 7 take away 3. And then you're going to write your answer wherever the bigger number was. Let's look at a couple of quick examples. Okay, so in this first one, I have x squared over x to the 8. So instead of writing out all the x's every time, let's use our trick. 8 take away 2, because we know 2 are going to cancel, leaves us with x to the 6th, but they will be at the bottom where the bigger number was. Now I have x to the 4 over x squared, so 4 take away 2 is 2, but I'm left with those x squareds on the top where the bigger number was. So I could just write x squared. So let's continue to work with this little nifty rule, and we'll write it up here. So when we are dividing, we're going to not add, but subtract our exponents. And then, as a little note to ourselves, write it with the bigger number. So our bigger exponent, if it was on top, then we'll write the answer in the numerator. If our bigger answer was in the denominator, we'll write it down at the bottom. Okay, so when we divide, we're going to subtract our exponents. Keep that in mind. So for our last example here, we can do some division. 20 over 15 would simplify to 4 over 3 if I divide by 5 and divide by 5. Now I have x to the, there's no power, so that means it's got to be a 1, over x to the 4. Well, I know that these x's are going to cancel, and I'll be left with x to the third power on the bottom. I said x to the third power because 4 take away 1. 4 take away 1 is 3. So after the cancellation, I'll be left with 3 of the x's, and they're going to be in the denominator where the bigger number was. I can also cancel my y's here. I have 8 y's on top, 3 y's on the bottom. So 8 take away 3 leaves me with y to the 5th power on the top. That would be our answer. Now let's actually do one of your homework problems. 6x to the 8th divided by 12x to the 4th. So look at what we did in our last example. We divided our coefficients first. So we'll simplify. Leaves me with a 1 in the top and a 2 in the denominator. And then simplify x to the 8 over x to the 4. Go ahead, try it yourself. So I should be left with x to the 4th in the numerator. Here's the work that you could show if you needed to is x to the 8th on top, x to the 4th on the bottom. 8 take away 4 leaves me with 4 x's in the numerator. So I'm going to rewrite this finally as x to the 4 over 2 since I don't need the 1 here. Okay, now let's go back to our rules. I'm going to teach you something new. And I just have to teach it to you up front. If I have x to a negative exponent, let's make a note to ourselves. We always want to get rid of the negative exponent first. So you'll start seeing problems where you have negative exponents, and the very, very first thing I want you to do is to get rid of the negative exponent first. And here's how. You can transform x to the negative m is really rewritten as 1 over x to the m. Look at what happened. My exponent changed from negative to positive, but only when we moved our base from the top, or the numerator, because technically this is like x over 1, to the denominator. Okay, so you can transform your exponent, get rid of the negative, but you have to move the base. So this was x in the top, it moved into the denominator. Similarly, and notice that what we're really dealing with here is a reciprocal. It was x over 1, and now it's 1 over x. So similarly, if I have x over y to the negative m, I can get rid of my negative exponent like this. I'll take the reciprocal of the inside. That becomes y over x, and it's now to the positive exponent. So negative exponent really just means take the reciprocal, or move it to the other side of the fraction line. So let's look at an example. If I have x to the negative 4, I want to get rid of my negative exponent right off the bat. That means I'm dealing with 1 over x to the 4th power is now in our denominator. Similarly, if I have 1 over x to the like negative 5, that really means I just want to move my x from the denominator now into the top. So it'd be x to the positive 5. A common mistake people make is that they leave the exponent negative even if they've already transformed it, but that would be incorrect. Once you take the reciprocal, your sign switches for your exponent. Okay, let's look at example 9. So in this example, there's two things going on. I have a negative exponent. I also have some stuff that can cancel. So let's deal with both. First, the negative exponent. If I have y to the negative 2, that means I actually have y squared. In the numerator, I have y times the y up top. So I moved it to the other side of my fraction. Same thing I had done here, right? It moved to the top. And now I have x to the 5 over x to the 1. Well, if I have 5x's up top, a 1 in the bottom, that means I'm left with x to the 4th in the numerator. I canceled these basically, and nothing is left down here. So my final answer is y squared x to the 4th. So look at what happened with my negative exponent. I simply took this y to the negative 2 and made it a y to the positive 2 up top. Okay, problem 1D from your homework. Well, if we're dealing with negative exponents, the very first thing we should do is get rid of them first, right? So negative exponents first. So we have to rewrite this. H to the 3rd times k to the negative 2 is really, I'm going to have to move this k squared to the bottom. So check it out. My positive exponent just stayed where it was. H cubed stayed on top. But k to the negative 2 had to move to the bottom and become a regular exponent. Divided by I'm sorry. This problem, let me rewind a little bit. This problem before I deal with my negative exponent, I would actually like to get rid of this division sign. Okay, so first I'm going to just rewrite it as a fraction. Like this. H cubed, k to the negative 2, divided by 2h to the negative 2, k to the positive 4. Okay, that's the first thing I wanted to do because all of the other examples we've done have been in fractions instead of division symbols. So now this makes this problem super easy. That k to the negative 2 should move to the bottom. And this h to the negative 2 should move to the top. They both just need to switch spots. So I'm left with h cubed. That guy didn't move. Oh, but now there's another h squared up top. So if you think about it, we really have a total of h to the 5th in our numerator. I'm just skipping ahead a little bit. Let's see what happens now. I have k to the negative 2, but it goes to the bottom as k squared, like this little ghost right here. But it's joining 4 other k's. So you can write k to the 4k squared, or you can immediately just join them as k to the 6th. And then don't forget we have this 2 in the denominator that just stays. So 2 down here, 2 over here. And that's our final answer. Let me do one more because that looked like it could be a little confusing. So again, you want to get rid of negative exponents. So this x to the negative 3 actually becomes an x cubed on the bottom and joins with this x squared to give us x to the 5 down below. This y to the negative 5 would join up with this y to the positive 1, leaving us with y to the 6 up top. And then we have our coefficient that we should not forget. I just wanted to do another quick example so you could see the pattern. All right, last problem. Number 2D. So I see a negative exponent. I want to get rid of it first. And the way to do that, remember, if I had x to the negative 7, we took the reciprocal of the inside, 1 over x to the positive 7. This time, instead of just a simple variable, I have like a whole mess of stuff, but that's okay. I still use the same rule. Instead of all that to the negative 2, I'm really dealing with 1 over all of that to the positive 2 power. Now, this is like an old problem from before. I'm going to distribute that 2 to these 3 different spots. So I'm going to get negative 2 squared, which is positive 4. I'm going to get h cubed squared, which is h to the 6th power. I'm going to get t to the 4th squared, which is t to the 8th power. And that's our answer. All right, I hope that helped. Thanks for joining me. Have an amazing day.